Welcome everyone, we're ready to start. Hello, so it's a pleasure to welcome you all to today's lecture. My name is Amparo Galindo, I'm a professor of chemical engineering. I'm also the co-director of the Institute of Molecular Sciences and Engineering. Nick Harrison is my co-director, and he has just reminded me to remind you to please put your mobiles on silent. I just did that with mine. So with that, let me tell you a little bit, about IMSI. IMSI is one of 7 Global Challenge Institutes of the college, in which we work to draw together the strength of our 4 faculties, and in particular in IMSI, we address challenges in which molecular innovation plays a central role, and we deliver solutions at engineering and function level. And so, as I say, we draw from all faculties on a theme of interdisciplinarity, transdisciplinarity, and welcoming people from all backgrounds to work together. And in fact, this follows very nicely the theme of talks that we've had earlier today. We've had a very inspiring day on the theme of water, sanitation, and hygiene. We had a panel of experts. I took a few notes on my phone very quickly where we had the panel of experts. And interdisciplinarity came up as a way of working, where interdisciplinarity goes beyond science and engineering towards social sciences, towards inclusion, equity, and we also discussed nomadic science, meaning that we go beyond our countries of origin and we really embrace global problems in a global way. So it's been an absolutely inspiring day. And as the highlight of today, now is our annual lecture. This is our flagship event of IMSI that we run once a year. Thanks to a very generous gift from Dr. Theo Wilson, who is an ex-alumni, an alumni of the chemistry department. He graduated in 1952 with a PhD in chemistry and then went on to a very successful career in medicine in the US, where he lives still today. And he gave a very generous donation to the college, with the aim explicitly to facilitate interdisciplinary research, and he suggested that we do this through a series of lectures, high-level lectures, bringing people from around the world addressing global challenges. So this is a special thanks to Theo for his support of this. And so today, it's a great pleasure to welcome, I have this written up, to welcome Professor Francis de los Reyes, who is a most distinguished professor from North Carolina State University. And I have his CV written up because, bear with me for a second. He's, as I say, extremely distinguished and has many awards, so I will go through some of the highlights and embarrass you slightly. I'm sorry. Okay, I'm going to swap microphone. Okay, so Francis is the Glenn and Phyllis Futrell Distinguished Professor of Civil Construction and Environmental Engineering, and alumni distinguished undergrad professor at North Carolina State University. He's also faculty in microbiology and biotechnology and a university faculty scholar, an honor that the American universities give to some of their most distinguished professors. He received his BSc in agricultural engineering, magna cum laude, from the University of the Philippines at Los Baños. I will say that again. For those of you, you can probably tell from my accent, I'm Spanish. Los baños in Spanish means bath, as in the bath that you have in your bathroom. So I don't know if that, if the theme has followed you through your career. There's something there, universal karma. So anyway, so he got his BSc from Philippines at Los Baños, as I say, and then did an MSc in civil engineering at Iowa State University and continued to a PhD in environmental engineering from the University of Illinois at Urbana-Champaign. Francis's research focuses on biological processes in waste and in wastewater treatment and conversion to resources, in environmental biotechnology and microbiology, as I was saying before, his faculty in those areas as well, global water, sanitation, and health in low and medium income countries. He has research collaborations throughout the world. So as I was saying before, this really follows the theme of aiming to do research that is truly global and not just, Western-centric, let's say. So he collaborates with the Philippines, India, China, South Africa, Pakistan, Kenya, Tanzania, and Malawi, which is, especially impressive. He has established and leads the Global WASH faculty cluster at North Carolina State University, and he leads a multi-university research effort in WASH infrastructure for underserved communities in the US and low and middle income countries. He's a TED Fellow. If you haven't seen him, he has beautiful TED Talks online. He's also a Water and Environment Federation Fellow and a board certified environmental engineer by eminence by the American and environmental engineering and scientists. In 2020, he was named corresponding member of the National Academy of Science and Technology of the Philippines, and he has received awards in research, in teaching, and in service, really truly distinguished in all areas of academic life. And this is from the Association of Environmental Engineering of Science Professors in North Carolina, of the Philippine American Academy of Scientists and Engineers, of the University of the Philippines, and also the Department of Science and Technology of the Philippines. Finally, his sanitation projects have won him the Reyes Environmental Challenge Award and the US Patents Award for Humanity. He's on the board of the nonprofit Gawa Kalinga USA group, and which works combating poverty and transforming the lives of the poorest 5 million people in the Philippines. Francis, it's a true pleasure to have you here today, so I give you the floor. Sorry, this was a slightly long introduction, but really I'm very happy to have you here, and we're looking forward to your talk.
Yeah, thank you.
Thank you.
Well, thank you, Professor Galindo, for the introduction. We're going to start with a little bit of a riddle. We're going to talk about a technology that's perhaps the most underrated technology in my mind in the world. We use it every single day, sometimes more than once a day. When we need it and we can't find it, we sometimes panic. And when we actually get to use it, we experience a lot of relief and sometimes bliss and happiness. So I hope you know what I'm talking about. Any ideas? Yeah, it's the toilet. So we're going to talk about the toilet. So today we're going to learn about crap. We're going to talk about shit. Perhaps the only time that in the Wilson lecture we're going to talk about these kinds of things. This is my favorite toilet in my house. And we started with a riddle. We're going to do a little bit of a quiz now. Okay? So these are pictures from all over the world. In the countries, there are 5 pictures. A, B, C, D, E, F. And there are 4 countries on the list. So we're going to do a little bit of a quiz, because we're at Imperial College. We've got to do that. So A, B, C, D, E, F. Japan, South Africa, England, and India. Any guesses as to what A is? Go ahead, Mike. Japan is which letter?
A.
Okay, that's a guess.
No, Japan is B.
Japan is B, okay. A good guess.
India D.
India is D, okay. A is England.
No, E is England. It's a posh hotel.
Okay, I hope that nobody's grading you all. You got Japan right. A is actually South Africa. It's a conceptual toilet that I took a picture of in South Africa. C is also South Africa. It's a beautiful toilet in the safari area. D was a trick question for you guys. That's the Tower of England. That's the garderobe, which basically, as you all know, it juts out of the walls of the castle. And when you do your business, the fecal material goes to the moat, right? Now, they've covered that in the Tower of England because they don't want you to see the stains outside the wall. But that was taken at the previous trip to the Tower of London. And E is actually from India, one of the most fanciest toilets I've ever seen. It was marble. It was in Chennai, marble, on 3 sides except the ceiling. So really interesting. And for a while in my career, I was kind of taking secretly, and when there was nobody around, pictures of toilets all over the world. So these are some more pictures. And of course, they don't all look like fancy toilets. They have different forms, depending on where you are. Maybe in South Africa, Kenya, Zambia, some of the places where I took some of these pictures. I'm over that phase now. I don't take pictures of toilets anymore. The reality is the toilet is just the first step in what we call the sanitation value chain. And a lot of emphasis has been on the toilet. So there's World Toilet Day, for example. And I keep saying that the problem with the World Toilet Day is that we emphasize the toilet. we should actually look at it as a system. It's a series of links in this actual chain. So the toilet is the user interface. And then you have perhaps containment or storage, and perhaps some treatment happening there already, but then you have to transport the fecal material. So in the business, we call it fecal sludge, fecal material, to the treatment, and hopefully to some form of recycling or recovery of resources, and then ultimately disposal. So we should take a look at this whole entire chain. Now for us in developed countries, in the US and here in the UK, we don't see this infrastructure. We see the treatment plant at the very end. Most of our waste go to a giant wastewater treatment plant, which we don't even sometimes know where that is, right? And our waste is flushed and transported through these giant pipes, sometimes hundreds of miles. So we don't see it. It's all buried, and we flush, and we forget it. But for billions of people around the world, it's not that hidden. It's actually very much open and very much seen and visible in the community. So on the left is a pit latrine, and in the middle you have a manual method of emptying a pit latrine. This is a very famous photograph that was taken in Burkina Faso. And on the right is one way of actually disposing of it in a body of water, and that was part of a video in Kenya. And so the problem is actually global. I think at this afternoon's panel, we talked about the billions of people. This is the latest data from 2020 from the World Health Organization. 3.6 billion people in the world don't have toilets at home whose wastes are actually managed safely. In other words, treated safely. Of that, about 2 billion don't even have basic services. And then you have people who are openly defecating, and that's exactly what that means, about 500 million. And then you have people who share their toilet access. And so this is important because this actually affects human health. And there's a lot of health risks associated with really not treating and handling the waste in the correct or environmentally safe way. So this is something called a shit flow diagram, and you can Google this. It's SFD, and I put the website there. This is an initiative by Susana, the Sustainable Sanitation Alliance, of which I am a member. And they put out these mass balances, citywide mass balances. On the left is 100%, all of the fecal material generated. And you're tracking the flow of that fecal material through the city. So this is for Dhaka, Bangladesh. And you can see that red is not good, green is good. So if you look at the percentages, for example, of off-site sanitation versus on-site sanitation, so off-site might mean that yes, it is flush, it may go to a sewer line, or more likely it's transported by truck. And then you have on-site sanitation through the different steps of the sanitation chain: containment, emptying, transport, treatment, and end use. And figuring out where everything goes. In Dhaka, Bangladesh, as of 2016, essentially, if you look at everything, really there's no green. Less than 1% of all the fecal sludge in Dhaka is treated in an environmentally safe way. 99+% is actually going to the environment in one form or the other, and it's not properly treated. And you can do this for different cities, and you can, again, look at that website. It's an ongoing project trying to quantify what's going on. You can do the same for drinking water. I'll spend most of my time today on sanitation, because that's really my first love. But I also wanted to show the concept is also true for drinking water. We do have a drinking water service chain, from extraction or abstraction to treatment, storage, and so on. And the worst case would be when I'm getting it from surface water. This is the most dangerous, most unhygienic source of raw water for drinking. And unfortunately, a lot of people in the world still do this. It's a little bit also more problematic in urban settings. When you have an informal settlement, how do you design a system for hundreds, maybe even thousands of people in an informal settlement. So these are a series of pictures. I didn't take them, but you can see the gravity of the situation where you have container trucks going into a community, and then people basically bring their containers. And the sad part is, on a per unit basis, per volume of water, the poor and the underserved actually pay more for water than we do. So on a per liter basis, they actually pay more. And so this is what's called a drinking water ladder, and I think this was referenced also in the panel, where basically if you compare the data from 2015 to 2020, blue is good, that's safely managed. And so you can see there is a slight increase in the slope from 70 to 74%. But that means 26% of the world's population still don't have safely managed drinking water. And so if you think about the SDGs, the Sustainable Development Goals, SDG 6, which is for water and wastewater, how can we get that to 100% in the next 7 years? 2030 is the deadline. That's the question. We talked about the billions, 3.6 billion for sanitation, but there's still 2 billion for drinking water, who lack basically safely managed services. And again, you can break it down. So the UN defines these different levels of service. This is almost obvious, but I always show this, just to show that it's not just the direct impacts, not just the diarrhea, not just the infections, not just the diseases that are caused by lack of access to safe sanitation, but there's also the consequent effects, the sequelae. For example, stunting or growth. So you have kids growing up who are going to be shorter, way less than peers who have access to safe sanitation, which may lead to things like even impaired cognitive function and other diseases like anemia. And then you have these broader issues of well-being, quality of life issues. Stress, for example. Imagine if you're a woman, let's say, in South Asia, and you don't have a facility at home, and you don't want to go out because there's no facility. So what do? You go out at night. Can you imagine holding your business for the whole day so that you can actually just go out at night, because for you that's less embarrassing? And there are other side effects of that. There are cases of sexual harassment. You have women and girls going out at night, and especially if you have communal facilities, that's where some of the young men hang out. And so you can imagine the situation where basically there's physical danger, and the ingredients for even violence occurring. And again, it impacts women and girls. And then if you think about long-term, what it means if women and girls and young children are having to collect drinking water, for example, maybe 1 hour, 2 hours every single day. What is it that they're not doing? They're not contributing to the economy of that country. They're shut out from employment. And for girls, for example, on the average, about 60 days of school are missed, because if they have, they're going through their menstrual period, and there are no safe facilities, private facilities in the school, they don't want to go to school. This is on top already of taboos with menstrual health management. So there are some of these impacts that are more long-term. So when we think about costs, we should not just think about engineering costs and first costs. We should also think about the costs that are not showing up in terms of materials and infrastructure. You should think about the cost of all of these effects, and it's very hard to actually figure out an exact number for all of these. In terms of disease burdens, the first column is basically deaths. And if you do the math, if you add it all up, it's about roughly 100 deaths every single day. So it is still a lot. And again, a lot of this is focused on children under the age of 5. Now, DALYs, that second column, is disability-adjusted life years. And so public health people quantify and have a formula for how many life years are lost, and that has a quality of life component to it. So for example, if you have a certain infection, it's not a whole year that's lost, maybe it's a fraction of a year. Hope that makes sense. That's just quantifying DALYs, and again, you want that to be as small as possible. So that's the impact. And if you add up all the costs, like I mentioned earlier, you can do it per region, and you will find that it's quite a significant percentage of GNP. There was talk of degrowth earlier during the panel. And one of the things that is really interesting is that we count economic growth as GNP, right? Gross national product, which is really just a really bad term if you think about it. And some people have said, you know, if there was an accident on the road, it actually adds to GNP, right? Because now you need a new car, medical services, transportation, and so on. But it really doesn't add to quality of life. But nevertheless, if you use GNP, you can see that in some regions, Sub-Saharan Africa, for example, it's 3.2% of GNP. And so on the flip side, if you look at the cost benefit, for every dollar we invest in sanitation, in Sub-Saharan Africa, it's about $5 in benefits. So it makes sense, right? Because every unit of money we put in investments, we get 5 times back in terms of the benefits. And again, considering all of the benefits that we see that I showed, not just the direct impacts, but also indirect impacts. Now, this is not just a Sub-Saharan problem, an Asian problem. In the US, we have 2 million Americans who don't have basic access out of 300 million. It's not quite well known. This organization that I also work with, called Dig Deep, has done this study. And basically, you have people who don't have access to their house, so they have to go out into some kind of connection, and they do this every single day. You have people in the United States, 1.4 million, who don't have indoor plumbing. This is called a straight pipe solution. So they flush their toilet, there is a toilet, but then it just goes straight out into a pipe, into their backyard, and you have a cesspool. And imagine, again, this is the backyard where, you know, the young children play in. So this is an issue that slowly is surfacing. And even in the US, we're saying this is an issue because this is the US. It's 2023, right? And the new MacBook Air just came out, M2 or whatever, right? We have Wi-Fi, we have all of these technologies, and yet we have millions of people in the US who don't have access. Now, Dig Deep just did a study, and it came out last year. What is the cost of all of this every single year? And they came out with this number, $8.6 billion every year. That's the hit to the US economy. And that's trying their best to look at some of these impacts. And again, obviously, it's an estimate. But if we're going to try to change policy, we want to put a number to it, right? We want to make sure that politicians and policymakers understand this is the cost, aside from the arguments about leaving nobody behind. Okay. This is a map that was constructed by the NRDC in 2019. It's a county-by-county map. So in the US, the cities and states are divided into counties. And basically, it's the intersection between water quality violations and the demographics of that county, whether by language spoken, or race, or skin color. And so basically, that intersection, the darker that spot is, the more you have a correlation between income, for example, and water quality violations. And if you look at this, basically, NRDC, the conclusion was this. The primary predictor of water quality violations is basically income, okay? And also related to the demographics. So our vision, and I say our, it's a collective vision, is basically a world where everybody, regardless of where you're from, you have access to basic, you have access to safe and sustainable sanitation and clean drinking water. So when you think about how do we realize this vision, so that's the problem, right? But how do we actually realize this vision? Well, it's a complex, we heard wicked, we heard multifaceted problem. So how do we solve this? Well, to me, it requires that we are intentional about this. It requires that we actually put a concerted focus on this. It's got to be also interdisciplinary. These are things that require us to rethink how we're doing things, including how we teach our students and how we do research. And so I'll talk about some of these things, some of these concepts, and hopefully we can have a really good discussion after. So I talked about SDG 6, something that perhaps all of you know, and these are some of the goals. How do we achieve universal and equitable access to safe and sustainable drinking water and safe and adequate sanitation? I wanted to highlight also ending open defecation and then paying special attention to the needs of women and those who are vulnerable. And I also wanted to highlight that SDG 6 is actually connected to all of the 17 other SDGs. It impacts poverty, it impacts gender issues, it impacts food and hunger issues. And so this is a diagram by Susanna, the Sustainable Sanitation Alliance, that it's too small to read, but I just wanted to show you that you cannot take these SDGs alone and independently. They're all really interconnected. And SDG 6, in my mind, impacts a lot of these things, as hopefully is obvious. Okay, so here's the question. Why don't we just solve the sanitation problem, right? We know it's a big issue. We know that for every dollar we put in, we get 5 times our money back in Sub-Saharan Africa, right? And 3 or 4 times in some other areas. So let's just go ahead and solve it. So to me, there are 4 key areas that we need to solve and we need to address. So let's go through them one by one. And I want to talk about these in the context of the global south, but also the global north, in particular the US. So the first one is a catch-all phrase, which I would call the enabling environment. And what does this mean? It means a lot of different things. It means government policy. So if you go to a particular developing country, a low or medium income country, obviously sanitation is like a poor second cousin to water services, right? I mean, water, it's very sexy. If you have a water project, it's obvious. If you don't have any clean drinking water, the impacts are quite obvious. But sanitation is still an afterthought. Nobody wants to deal with it, right? My favorite example is, if I'm a politician, I'd rather that I cut the ribbons for a well project. But what about toilets? It's not very sexy, right? Maybe I don't want that PR campaign. So it's invisible. And even when it's visible, the bias is towards sewerage. In other words, the solution is, let's put sewer lines and let's have a centralized wastewater treatment plant. And I will argue, and you'll hear more about this, that that's probably not the best solution for many, many situations. And it's often stopgap in poor areas. How do you, again, think about informal settlements? And how do you think about providing water and sanitation services if fundamentally these people in informal settlements are actually not the legal owners of that land, right? So there's really a big, big issue. We have limited data. In the US, that map that I showed you and that underlying data is the best that we have so far. Individual projects, individual NGOs, individual universities have data for their communities, but there's really no central place where we can query that data. We don't really know exactly where the septic tanks are. We don't really know exactly where there is access or not access. So a lot of this is basically individual projects going out and trying to get the data. Lack of human resources. If you go to a developing country, they don't really have enough engineers that are trained in environmental engineering that can do the microbiology, that can do the chemistry that's needed, the process engineering side. And then lack of integrated planning. Many of you have probably traveled to different countries, and you will see that there's really no integrated planning. People build on top of one another, and it's really very hard to think about a city-wide or even a watershed-wide kind of planning. It would be nice if we can do that, but cities are kind of like evolving and over time. So all of these, the policies, the regulations, these are all part of the enabling environment. And so we got to try to address these. So in the US, the centralized systems are still the main paradigm. There is increasing talk now. I'm very happy to be part of a couple of task forces by the Water Environment Federation, and it's called the Distributed Water Infrastructure Task Force. It's only now that we're trying to think about not centralized systems. You probably heard of the giant, bipartisan infrastructure law in the US. So the Biden administration has put a lot of money. And there's something called the Justice 40 Initiative. And what this is, they're basically saying that 40% of the money has to go to disadvantaged communities. So now we have to define, okay, what's a disadvantaged community? And there's different ways that people are trying to define this. Each state is trying to figure out what to do with this. Unfortunately, the money for this, like in North Carolina, I'm part of another committee that's deciding on investments based on some of these new funding. But the legislature has given us the mandate for improving existing systems, failing systems that are existing. And so the question is, what do we do for those who don't have systems? And that's out of scope. So in other words, it's good that those failing systems are going to be fixed, but then you have a lot of systems or communities that don't have systems, and they're pretty much shut out from this funding. Okay. We talked about limited data. So in the US, in the 1980s, they removed the census question. So we don't really know, who's got a septic tank, who doesn't have a septic tank, who's got a septic tank. So they just removed that. So we don't have that data. And then water reuse regulations need updating. So for example, in North Carolina, where I'm from, if you take a bath, you can actually not use that bath water. Technically, you're allowed to use a little container, and if you manually use that to water your plants, that's fine. But as soon as you make that part of your plumbing, you have a pump or a hose, that's not legal. So our regulations have to catch up with reality. Otherwise, we'll keep doing what we've been doing, which is we're using drinking water to flush our toilets. And as you know, that really doesn't make sense. And then finally, who's got the voice? And this is true anywhere, but in the US particularly, we're talking about underserved communities. We're talking about communities who really are not active politically and can be shut out of that process. So we're talking about all of these underserved communities, and we do have arsenic, we do have PFAS violations. I talked about the black and rural belt in Alabama, the straight pipe solutions, and people who basically have to fill up at night because they don't want their neighbors to know that they don't have access to clean drinking water. And then finally, as part of this enabling environment, no one talks about it. Okay? Like I said, nobody talks about what goes on in a bathroom. So one of the things that I like to do is I Google celebrity support for water. And this was, I think this was a few days ago, so very recent. And I just took the images. So you see Matt Damon, he's pretty cool. Gwyneth Paltrow, sorry, I had to think about her name. Rachel from Friends. Jennifer Aniston, thank you. And there's again, supporting water is nice, right? You got celebrities. And now the surprise is it's gotten better. So I type now, Google's, celebrity support for sanitation. And it's a lot better. So before, it was all kinds of things that I can't show you. But now it's still Matt Damon because he's pretty cool. And there's a few other, Richard Branson and Rihanna and Angelina Jolie. Okay, thank you. So there's still now, it's becoming more legitimate, right? Google, if you celebrity support for sanitation. And I don't want to show you what happened when I Googled celebrity support for toilets, right? But it's becoming part now of the conversation. And I think this is an example, right? What we're talking about here at IMSE is an example of this issue, becoming more and more visible to people. For my part, I think it was referenced, to me, there are some forms that can be more popular. For example, there is a TED Ed animations. I don't know how many of you actually watch TED Ed. This is like animation. And I did one a few years ago where basically we had a talking poop emoji. And I was really surprised that it's got over 4 million views, and it's being used by middle schoolers and high schoolers. So to me, reaching out and spreading the word, I think is part of what we should do. Okay, so the first one was what again? Enabling environment, right? Talking about it, policies, pressuring politicians. The second one is, how do we think about economic opportunities and incentives? For this to scale up, it's got to make sense, right? We talked about the benefits and costs, but how do we make that real? So for example, looking at the sanitation chain, can I have small businesses actually start collecting the waste and get paid for that, and maybe use the waste into something that's valuable, let's say fertilizer production. So this is an actual process in South Africa where they do this. Is this possible? And we've shown with some of our research, we've got a paper out on this, that yes, you can have a business model where it actually makes sense. Can we use the products from fecal sludge? Well, we know how to do some of these things. We know that we can turn that into soil conditioners, we can reclaim the water, we can even use it for building materials. So another example I visited a few years ago in Stellenbosch in South Africa is a company that uses the black soldier fly. And what the black soldier fly does is basically they eat waste along with food waste. And then what you do is you harvest the larvae. And so that's the larva of the black soldier fly, and you dry it, and it becomes an alternative protein source. And that can actually substitute for oil meal, fish oil meal, for example, that's used in animal feed. And so it can be scaled up. It may not work for every particular context, but it is possible to do all these things, convert fecal sludge to animal protein or protein for animal feed. We can get energy from fecal sludge. So a lot of my colleagues, here, we working on things like anaerobic digestion, but that's just one pathway. So we can do all of these things. We can generate heat, electricity, and even biodiesel through some of these pathways. And the question is, are they all technically feasible? Yes. But are they all really, from a life cycle standpoint, will it all make sense? It depends. It depends on a lot of different things, including context, where you are, which country, how dense, and so on. There are all kinds of issues that have to be resolved on a context basis. In the US, it's a little bit different. How do we do these economic opportunities and incentives? It's a little bit complicated because our model is this, right? There is a utility or an RME, responsible management entity, that basically interacts with all of these other things. And then there's a customer that basically pays, right? That's a traditional model. It's the same model here in the UK. If we're talking about a different kind of model, let's say a more decentralized model, who's going to pay? So now you have maybe the owner is the beneficiary. If you are taking care of your own system, who's going to manage it? Who's going to own it? Who's going to pay for it? All of these things are in flux. And the nice thing, the good thing, is that the discussion is happening right now in professional societies. We're trying to rethink some of these things. Because again, somebody has to make money here, right? But who's in charge of what? And that's part of the issue, is that the cost of centralized systems, at least in the US, is hidden. Because I don't see it. It's part of my tax. But the cost of a community system falls on the community. The cost of a household system falls on the household. And so how do we rethink those ownership structures, those management structures? These are some of the things that people are thinking about right now. Okay, so the first one was enabling environment, economic opportunities and incentives, and the third one is social and behavioral change. There are still stigmas in terms of professionalizing the sector. And these are, again, the manual pit emptier. This is a picture from Dave Still, and there's an emptier right there. He's got a face mask on, but no shirt. And again, manual emptying is still a practice in many countries. Well, I want to show you a video. It's short, but I should have a disclaimer. It's a little bit on the graphic side. You've all had lunch already, but just turn away if it's too much.
Ito ko promotion na.
Dio kahora ni kana kuwa. Dio kahora.
Ndio slow. Akuwa kawaida. Ngeni. Baada ya hapo. Bambe. Bamba dinga. Alikuwa anataka ubambe. Ile kidogo.
Asimenyo ko kat nenda.
Okay, so you've heard of MOOCs, right? Massive Open Online Courses. So I call that massive open defecation. So basically, several months, several months of fecal sludge basically just dumped right into a receiving body of water. How do we think about this? How do we change the behavior, the attitudes? How do we even think about hygiene in that kind of situation? So these are some of the questions, right, that we have to think about also. But it's not just, again, not just in Sub-Saharan Africa or Asia. It's also happening in the US. These are pictures from Dig Deep. These are in Alaska. And basically, those pipes are straight from toilets. And they go into this nice, clear stream in Alaska. And if you ask them about their sanitation status, they won't actually give you an answer because they're afraid that are we in violation of something? Or are we going to be fined and penalized? So there is this behavioral change aspect to it. Of course, there's manual scavenging also in India, which is technically illegal, but it still is happening. And that's on top of the caste system that's also present in India, where the lowest caste, the Dalits, are really forced to basically clean and empty the pit latrines of the middle class. It's still happening today. And with the caste system, the really sad part is they're training their young children, girls ages 8 and below, to actually take over that same job. Right? So how do we change that? That's really very hard because that's hundreds of years of history and culture and tradition that we're fighting against. So there's a whole aspect of our toilets and sanitation being part of religion, being part of culture, and how do we address those issues? And then finally, technology that addresses inequities. So the first question is, and I have a series of insights here that maybe we can think about as researchers and scientists. What is aspirational technology? What is it that we want to happen in low and medium income countries? So one philosophy is, if it's good enough for them, it should be good enough for us, right? Is it this, Gates Foundation inspired toilet? Yeah, I mean, maybe that's an answer, right? But we need to think about this. This is a picture of a pit latrine in Malawi. I just wanted to contrast, where should we go in terms of this? What's the meaning of technology that's really appropriate? And again, I don't have the answers. I'm trying to think through the questions so that we collectively can really figure this out. The second insight is that, again, it's not just the toilets, right? It's the whole entire sanitation chain. And to me, this is kind of like a fractal. I can zoom in and zoom out and really think about the different questions I can answer. So let me just get a few pieces out there. So for example, how do I think about health risks? You know, you saw that video. What's the health risk of all of that, right? To the workers, to the community, to the people living in that area. What kinds of emptying technologies do I need? And so in our research, we have developed a pit emptying technology, a mechanized way of emptying pits that's more hygienic. And it was developed and tested over many, many years. And it's ready for commercialization. And I'll talk about that a little bit. What about building materials? What about lighting and flies, the environment? What about new hydrophobic materials that actually you don't need water to flush, right? Everything will just slide off. What about biodegradation and microbial community structure happening in the pit latrines? So we have a project in Malawi, for example, that we're looking and using molecular analysis, DNA and RNA-based methods to look at the degradation processes inside these pits. What about waste-based epidemiology? Today we use wastewater-based epidemiology to look at things like COVID or norovirus or flu or polio in wastewater. But what about those who are not connected to a sewer line? Can we actually use those same technologies? So we have a paper we just submitted on this application. What about the social science of this and the operations research, the optimization of transportation and so on? And that's just on this side, right? On the treatment side, there's all kinds of technologies that can be used. On the monitoring side, sensing side, and then the systems analysis of it all. What is optimal for a community? What will make the most sense? So there's a lot of research questions, and you can zoom in or you can zoom out like a fractal in a lot of these areas. So I hope you're excited by some of these questions that we can actually answer and maybe help in solving this issue. The third insight is that maybe we should move away and reimagine our infrastructure from centralized to more distributed and hybrid systems. So all of our training, a lot of our training, at least in the US, has been towards this large wastewater treatment plants. For many years, that's what I did. I taught students how to design these large treatment plants. But so now the question is, how do we actually reverse this and think about more decentralized, distributed solutions? Because they have advantages. So they have economic advantages. I'm not pumping large volumes of water around for many, many miles. And so in theory, I can save 50% of the energy costs and 50% of the associated emissions in carbon, and maybe even 75% of the water, because I can reuse the water, right? If I have, for example, gray water technology. Environmental footprint, and then the social aspect of it. So on all three fundamentals of sustainability, economic, environmental, and social, there are advantages to distributed systems. So rethinking this requires that we think about different scales. So here's a small community scale. Here's a cluster of homes. Here's a house. Can I develop technologies all along these different scales so I can minimize the water that's used and again maximize the energy savings and maximize or minimize carbon emissions? And can I do that so that people can really afford this? So I guess we can have to think about, again, ownership and all of those things. And how do I use the power of technology? You know, everybody talks about data and machine learning and AI. But how can I actually use sensors, which gives me a lot of data, and how can I use that data to optimize so that, and in the end, and I think somebody from Michael Templeton's lab, I talked to somebody earlier, developing an app, right? And so the idea is that I'm a household owner, I have an app on my phone, and I can check my water quality, how safe is my drinking water in real time, right? And how can I collate all of this data so I can keep improving my physical system with my virtual system and vice versa. So last May, we submitted this giant proposal, which took up almost a year of my life to put together. It was a research center and hopefully we'll be successful. But one of the concepts was, what is the house of the future of water? And the idea is, well, let's buy a house. Let's outfit the house, let's have people live in the house, and let's actually showcase and test the actual technologies that we're talking about. How do we reuse gray water? How do we start thinking about urine and resource recovery? How can we integrate other sources of water like rainwater and show that, yes, we can achieve that 75% reduction in water and 50% reduction in energy. So hopefully, if we get that funding, we actually can show this house, build this house, and then do a long-term study of how much is this thing going to cost and can really make it work, right? It's got to be reliable, it's got to be affordable, and all of those things. So we're excited about this. So a lot of different technologies that we can actually look at in terms of sensors, in terms of drinking water, in terms of wastewater. If we compare the current state of the art versus what we should be thinking about in the future. Again, what's the future of water and sanitation infrastructure? So we do have, I can't go into a lot of the details, but imagine if you have sensors, right, that are cheap and affordable and online. And at any given point, I can check what's happening with my drinking water, with my wastewater. Think about how that would engender trust so that people don't have to take showers with bottled water, which is what I heard. Right? So that's kind of like the role of technology and the future of this. There are lots of things we have to figure out to make sure that this is sustainable in the long run. But we got to rethink and say this centralized treatment of wastewater and even of drinking water is not going to be the right solution for everybody. Some places are just too far, too expensive. Maybe they don't even have water. So we got to rethink all of these. And so it's a not one size fits all. It's context dependent. And number two, it's got to look at the whole system, right? It's not just the first cost. It's got to look at the life cycle costs, and it's got to look at what's good at a larger scale. The fourth insight is that this cannot really happen if we don't involve communities from the get-go. So co-design is a big important factor. This is a figure from that research center proposal I was telling you about, where basically the communities are there. They're part of co-designing, they're part of engineering workforce development, research, this concept of a virtual test bed. How do we actually have this online test bed? And it's not just the communities, right? Our researchers, our students. Imagine if our students can actually work with communities and engage with communities. That's the new breed of engineer we're talking about, right? They've got their skill sets in terms of their discipline, but they're also prepared to go out and talk to actual community members and co-design with community members. And then finally, industry. This is not going to happen without this particular, the industry, the sector that actually stands to gain a lot. We talked about billions of people around the world. Well, that's a huge market, right? And we make this case, again, for US companies. Well, that's a market for US companies. Do you want to be a global leader? There's this demand, and it's not going to go away. And so we need sensors, we need technologies, and so we need to have them all work together in this community engagement model so that we know this will be adopted and this will scale up and this will work in the long run. So I just wanted to put this up because I wanted to show off my poop shirt. That's really it, sorry. But pictures of community engagement and going out and perhaps getting our students to do the same. The fifth insight is that we as researchers, we have to go out into the field, right? We have to fail in the field and fail over and over again. So in our example, one of the things that I really learned was that we iterate between the lab and the field. We design these things, we build them in our lab, and then we go out to the field, and when we find out it doesn't work, or people don't like them. And so we have to lick our wounds, go back to the lab, redesign, and then go back out again. And so I'm showing you different places where really, you can also kind of follow the evolution of this particular technology, in different places. And we kept failing for many years. And I think that's really the lesson, right? You don't want to fail. Ideally, you fail fast, right? But if you just do it in the lab without going out, we will never know if it's really going to work, right? And so this is the final form. This is a commercially ready product. And so as a researcher, I was thinking, yes, we got something. We've solved the spit emptying problem, right? Let's go out and get a commercial partner. And you know all about the valley of death, right? We got the funding, and in this case, the Gates Foundation. We got the funding to do a lot of this work. We tried very hard to get commercial partners. But what we found out in this particular field is that even though we showed that there's a business for this, you can get a profit from this, you're going to make money, you're not going to lose money, still we didn't have, a bite. People were interested, but they wanted more, they wanted more investment from the foundation or from the government. And what we found out was that in this particular sector, what you need are partners who are not in it for the profit alone. They have to be also willing to provide the service. It's going to be part of their DNA, their vision, right? And so, because if they had a choice, let's say it's a pump business. Well, my pump business is earning 10, 15, 20%, right? Your pit emptying machine, if I retool and build that for you, distribute it, market it, sell it, I'm going to earn 3%, 5%. So why should I go into that particular sector? That is what we basically were facing, even though we show that it actually will make money for you. So just an insight, which we haven't solved yet. I just realized that this is a unique need. And how do we actually go about solving this? So in the end, we need some of these changes. We need to get the data globally and even in the US. And I know a lot of people have access to all kinds of different data. How do we actually link all of these? How do we create a dashboard, a place where people can trust that data? Like, NCBI, for those of you who are biotechnologists, right? I trust that the sequences deposited there are vetted, I can use them, it's open source. How can I do something like that for water and sanitation? We need to remove some of these regulatory barriers that I talked about, okay? Some of these things, gray water issues, how do we reduce the risk and show. And our goal with the House of the Future is actually get all this data and show our regulators that, yes, we can do this, and it's not posing additional health risks to the people who are living in that house. Obviously, increasing support for alternative technologies and through the valley of death, right? That is still the age-old problem. And then long-term commitment to work with communities. How do we actually change how we think about research so that we're talking about citizen science, we're talking about community engagement, and through co-design, right? Not an exploitative, extractive relationship with communities, but really partnership. And this takes years, this takes time. It's not going to happen overnight. And so this takes a lot of work to build those relationships and a lot of trust building. And then finally, how do we get our industry, innovation ecosystem partners on board, right? Because, the private sector has a role to play here. And how do we do that so that we can build this together? And I didn't really touch on this, but maybe I mentioned, in terms of education and teaching our students, I think there are two components. One is we need to send, and I'm talking about US students, right? We need to send them out of the US so they have an international experience, because that just broadens the mind. And then second, they need to be working with communities. So how do we think about this? How do we retrain our workforce? And in particular, I don't know about the UK, but in the US, we do have a shortage now of water sector professionals. It's aging, and it's not very diverse, and it's mostly male. How do we diversify that workforce in the US? So I'm not aware, or I'm not sure if in the UK you have that same issue. So in the end, I think we've made progress. I think we understand some of these things. There's still a lot of needs. It is still a challenge. But this is a challenge that we all need to think about and really think about how we can reimagine and transform water and sanitation infrastructure. And we need to do it now. So we can do all these things, develop these new products, reimagine, renew engineering education, excite the next generation of students, reimage the water sector workforce, but at the end of it, improve the health and quality of life of billions globally. There's a book that came out from the UK, and it's called The Spirit Level. I don't know how many of you have read that book. And it's basically talking about how societies need to be equitable, to be sustainable. So it's not just because out of the goodness of our hearts we're doing this. We're doing this because it's the right thing to do, and because that really makes us a true civilized society. So, thank you.
My goodness, thank you. It was very, very interesting. Quite, as someone who lived off-grid for years, with a septic tank and a well, and also love what we call wild swimming in lakes and rivers. It's very interesting and a little bit scary. So, thank you. We can take questions in the room. If you have a question, please raise your hand. And if you're online listening, please just add a question to the comments section and we'll get round to you and read it out. If you do raise your hand, wait for a microphone to come to you. We'll start there.
So I was going to ask, if you really had the choice, do you think that it's investment in sanitation, or is it investment in economic development which allows sanitation that needs to happen first?
That's a good question, because I think the panel was right? I think at the end of it, the root cause is really inequity, and economic inequity is the root cause. But I think some of the things that we talk about today are really more specific to sanitation and water. Because I think even if you do address, so to me it's not just a money issue. First of all, I think there are some real interdisciplinary problems that we need to think about. Because in the US it is a problem, right? And you can argue, oh, we can just throw money. But no, actually, these communities, these 2 million people, the reason that they're in that situation is that they cannot be connected to sewer lines, for example. It's just not going to work for them. It's just going to be too expensive. And even in the US, we have a failing infrastructure in water and wastewater. So it's really putting more money into this thing when, if you think about it, there's probably a better way of doing things. So it's not just a money issue. But I do agree that it's really related to economic inequity, and obviously that will go a long way. A nice example, I don't know if you know Derek Jeter, baseball star, New York Yankees. Sorry, very American. Let's just say rich sports guy. He's got a wastewater problem. He lives in New York. He lives in a nice multi-million-dollar house. But his waste goes into essentially a pit latrine. So it's not the money that's the issue. Even the rich have an issue with what technology do I put in here. So yeah, I guess it's really multifaceted. Yeah.
We had another question.
Thank you for a really great presentation. I wanted to ask a question around the interdisciplinarity, because I think we've mentioned it quite a lot today. So maybe, from the perspective, I don't know, maybe of the new project that you have applied for, how do you see the future of the interdisciplinary work in WASH? And is there a need for tools? I guess what I'm really interested in is how. So we have these nice diagrams when everything is linked. What is the next step to actually do that?
Yeah, so I'll answer that from a more of a theoretical standpoint and then also a practical example. So there's something called the science of team science, which is really fascinating, right? I mean, there's really literature. There are people who try to understand team science and how do science teams work together and what would be an ideal change so that, for example, you get the different disciplines happening and you've got a more inclusive teams working together. So that's something that maybe, it's fascinating. And the National Academy of Engineering has published some of these papers out there. So it's available online. And so what I've learned from talking to experts in team science is that at the end of the day, it's all about trust. Researchers come together and work together because they trust each other. And building that trust, at the end of the day, we may have our miscommunications, we may have our issues, but if we build that foundation of trust, then interdisciplinary research, should work. But that's a fundamental, that's a needed requirement. So, for example, in WASH, I think I mentioned this at dinner. One of the proudest things I've done in my career is publish a couple of papers with social scientists. In one paper, we were talking about the roles of social scientists versus engineers and the common language that we need to share and how we approach things. What they bring is the context. They understand what works with communities, right? As engineers, we were not trained to really interact with different communities. But the social scientists tell us, okay, how do we approach this from a community building standpoint, a trust building standpoint? So I listen to what they say, and I've hopefully learned a lot working with them. There are medical anthropologists, for example, and we can borrow some of their methods too in social anthropology. For example, observational studies, right? They've done things like given people cameras and just take shots, take pictures of things that are important to you. And then when you come back, you analyze the data as images. Or they've done all kinds of surveys that are not your standard, paper and pen survey, but they have all kinds of interesting surveys, especially for people who, don't read or write. And so they have a lot of techniques that we can use. They always tell me, as an engineer, oh, you cannot be a social scientist. Let us do that work. And I tell them, well, likewise, you cannot be an engineer. But we can work together. And it requires me understanding some of your approaches and some of your language, and it requires you understanding about some of my language and some of my approaches. But that's built on trust. So I think fundamentally, we can make interdisciplinary teams work if we agree that these are, the things that we agree on. And so, for example, in this center proposal, I had everybody sign a covenant. It was a covenant, a research covenant, and it says, here's how we're going to share the data. Here's how we're going to think about authorship. Here's how we're going to work with each other. I see the signs in Imperial. I've done the tour. Those signs that says respect. It's the same thing, but for science. So now and how do we promote inclusivity and younger researchers, early career researchers? That's all part of that covenant. And as the lead for that, being explicit about that, I think helps with building the trust. I don't know if that helps, but yeah.
The majority of countries affected by lack of water, sanitation, and hygiene are often poverty-stricken and lack investment from their government. How do you plan to obtain the funding for this project to affect it on a global scale?
Yeah, thank you for that question. Really, really good question, right? And that's a question that a lot of people ask. And that is true. And I think in the panel today, too, I think that came out in that what we want to do is not come in and say, this is the solution, this is how you should do it, right? We have a lot of experience with that approach. It doesn't work long term. What we really want is we want to empower those same communities, those same scientists, to actually figure out the solutions. So we call this a global north, global south exchange. But coming into it with a humility that, yeah, we can actually have a global south, global north exchange too. We learn from them. I think it was Anna who said they have a lot of experience with decentralized systems, right? So we can actually learn in terms of all kinds of different things on the social science side, on the technology side. The more that we push on the need, the more that we're going to get a response. An example is India. India, the Modi administration has put in billions of dollars into water and sanitation as part of the Swachh Bharat, movement. Now you can argue that that's not 100% successful, but India has put a lot of money in it because they said, you know what, we have these skyscrapers, we want to consider ourselves, an industrialized country, but we have, millions of people defecating in the open. So it is possible for countries, and there are some success stories in terms of the joint monitoring programs. There are some countries that actually have gone a long way in meeting the SDG targets. So I think there is, if we make the case, especially the cost benefit, right? For every dollar you invest or for every rupee you invest, you get 5 rupees back. If we make that case, if we put the data in that we have the technologies, right? You just have to help us with this or that, then we can make a dent into this. And there are examples of governments putting money into these programs. But again, we have a long way to go because some other countries, it's not just their priorities. But part of it too is, and I speak also as coming from the US, right? You know that we have an election coming up next year again. Part of it too is us voting in the right leaders who are going to prioritize these things and not other things, right? I actually, I thought about putting another picture of a toilet, which had like document boxes. Don't know if, but I thought maybe not. But there are these memes now with toilet with boxes of military documents. I don't know. So what I'm saying is it's possible, and I think we can do our role here too, right? Even from where you are, from the UK. Yeah. But thank you for the question.
Thanks very much for your talk, Francis. Sort of building on that previous question about sort of innovative financing models, and it's also a molecular science question because it's the Institute for Molecular Science and Engineering. So one molecule you didn't mention in your talk was methane, and I think about 1% of global greenhouse gas emissions are from pit latrines or open defecation, basic forms of sanitation. Yep. And there's a current move, towards carbon credit markets where large companies and governments have to show that they're going to achieve net zero for climate change purposes. And to do that, there's an opportunity to invest in carbon offsetting by investing in technologies that reduce methane emissions. Right. So do you think this is maybe a mechanism that could be used to support sanitation financing in future?
Yeah, absolutely. And we actually have, I just had a student from Malawi actually do a study on methane emissions of septic tanks and pit latrines globally. And the summary of our study was that we are undercounting methane in some instances. If we factor in seasons and temperature and so on, we are underestimating some of the emissions that are known in the literature. But yes, I think energy, carbon, water, these are all interconnected, and I think we can make a case that if we do this right, we can also hit some of those targets. So in fact, that project I was telling you about, we explicitly said this is not just to reduce water by 75%, because the number you have was what, 168 liters per day? Well, in the US, it's, you want to guess? About 250 to 300, right? The nominal number in my design class is 100 gallons per day. That's 378 liters per day, right? But it's actually come down a little bit. It's more like 80 liters per day now. 80 gallons per day. Sorry, we're one of the few countries that still use this mixed units, right? So cutting down on water on a per capita basis, and then cutting down on the energy just by not pumping huge volumes of water hundreds of miles. So you take that out, theoretically, that's already 50% of the energy. And then technologies that are specifically utilizing methane or not producing methane at all. Yeah, so I think that's a really good point.
Hi. I hope that this is within scope, but you talk of like building trust with communities and decentralized systems. So I just wanted to ask how, because corruption has been a major factor in like delaying these services being deployed. Right. So when you reduce the scale, does that reduce your risk of corruption, or like if it does occur, how do you handle it without breaking the trust?
Yeah, so when you think about communities, frankly, a lot of our partners are not official government agencies or communities. We partner a lot with NGOs who have been on the ground for a long time. Because again, just building a new relationship takes time, right? So we partner with NGOs that work on the ground. It would be great if the local government unit can also be part of that. In my work with the Philippines, in a different context, we actually find that there are some local mayors and local councils, city councils, town councils, that are actually quite progressive. And so, to me, they're part of the solution, right? So we can't like paint them with a broad brush and say that's all corrupt. But working with them, and then just having, corruption is always an issue. But, just again, being clear and transparent about some of these things. Yeah, I don't know if I can really answer that question, yeah.
Hi, we're going to take a question from online. How can we effectively balance the provision of drinking water and sanitation services without jeopardizing freshwater biodiversity and threaten the ecosystem goods and services?
Yeah, it's a really good question. So first, I guess the balance between pressures, and so part of it is what we're talking about is actually reducing the need for water abstraction, right? Reducing the need, and this is very true now in the western part of the United States. California is talking about not just reuse for not just gray water reclamation, but actually kind of like the new water in Singapore, actually potable water reuse. There's non-potable reuse and there's potable reuse. So actually treating it to the level where you can drink it. And that requires a lot of investment and a lot of technology, right? But some of these decentralized systems on the drinking water side can be reduced by reusing water on the wastewater side. So really, again, the numbers are 75% reduction. So if you think about the numbers I was throwing out, 100 gallons down to 25 gallons. So now we're more in the 100 liters per day, per capita per day. So to me, that is going to help relieve the stress on the water demand side. So it's all integrated. So there's a concept called One Water that people have been talking about, right? How do we actually think about this, circular economy for water? And we tried a concept called One Wash. And again, same thing, water fit for purpose, and context adapted. So the answer is yes. If we think about water reuse and the wastewater side of things, we're going to relieve some of the stresses on the drinking water side. Yeah.
Maybe one last question? Did you have a second question?
Yeah, but at this point, because we're meeting tomorrow, but I'm so tempted to ask this question if I can.
You can, please do.
So it's really, appreciating the importance of central infrastructure historically, and how kind of the quality of society has depended on prosperity, has depended on sanitation.
Right.
Do you get the feeling that the trend of decentralization, decentralized systems, is in some respects giving up in terms of the expectations we have for the rest of the world to reach the level of prosperity we have in the developed world?
That's a good question, and I want to have it all. That's the answer. I talk about hybrid systems, right? And for people who are connected and it works well for them, and that's, drinking water treatment, wastewater treatment has saved billions of lives over the many years, right? And we should celebrate those gains and recognize that that has really helped. I mean, London was actually the first Bazalgette, right, in the sewer system. So we should realize that, yeah, I mean, that has its place. I think the push, me personally, my push for decentralized systems is to almost just balance the playing field. I'm a wastewater person, right? Like I told you, I've spent years, I still work with consulting engineers, and I train my students to design these large systems, because that's what they're going to do in the future. But I'm thinking, in my global WASH classes, I should also teach them how to design these other systems. So it's really a balance, right? And I think anytime there's balancing, there is an emphasis on the one side. It's kind of like diversity, right? And equity. You know, we might say, yeah, we have to think about everybody. Yes, but we're balancing. So if we're balancing, we're going to put more weight on the side that needs that help. That's my personal opinion. But philosophically, I want it all, hybrid systems. And whatever works, right? From an engineer standpoint, I want the optimal system for that community or for that homeowner.
That, I think, is a wonderful note to end on. Thank you very much.
Thanks.